Welcome to BCIS 3347. My name is Dr. Schuessler, and today's topic we're going to be talking about Chapter 1, an Introduction to Networking. So this is our Blackboard shell. If you haven't looked around that much, I've posted the slides in our navigation bar over here on the left-hand side. So let's scroll on down and take a look at that. So here we have slides. I've taken the PowerPoint presentations from the textbook, and I've started converting them so I can add additional content and change them as needed. So I've modified the way they look. So I haven't done all of the chapters yet. I'm working my way through them. The very first one is Chapter 1, and that's the one we're going to be looking at today. So we can go ahead and click on that, and we will start the presentation here in just a moment and jump on in to Chapter 1, an Introduction to Networking. So let's full screen that. And there we go. So Chapter 1, Introduction to Networking, and all of that good information there. So the objectives for this chapter are to talk about the advantages of networking computers relative to just a standalone computer. Obviously, we gain a lot of power by being able to network computers and combine and share resources. So we'll talk about that. We're going to distinguish between clients and servers and peer-to-peer networks. We'll talk about some of the common elements to all client-server networks. We'll describe several specific uses for a network. We'll identify some of the certifications that are available to networking professionals. And then we'll finish up by talking about different kinds of skills and specializations that'll help you excel as a networking professional, help you get a job, and all that kind of stuff. So before we jump into why we should use computer networks or why use networks in general, we really need to talk about what a network is. And in its simplest forms, a network is nothing more than two or more networkable devices or two or more computing devices that are connected together. By doing that, that allows us to share things. It allows us to share resources, sharing a printer, sharing files, sharing storage, things like that. So that's why we want to be able to use networks, is it allows us to share things. Now, a standalone computer doesn't allow that. We're not really connected to any other computers. Anything that we need has to be loaded locally onto that specific system. So we're using local software and local data. So some of those advantages to networks, again, device sharing, multiple users, we can save time and money, and we can also centralize network management. Now, when we talk about networks, we tend to talk about different types of models of networks, and there's lots of different types of models. There's lots of different ways of looking at networks and categorizing different types of networks. And some of these different models are based on the positioning of computers. They're used to describe how control is done over various resources. How communication and resource sharing schemes are implemented. So there's different ways of looking at network models. One common way or one popular way is to look at whether or not it's a peer-to-peer network versus a client-server network. Now, a peer-to-peer network is a pretty basic network. Every computer on the network has the same authority. In other words, they're equal systems. There is no client, there is no server. They're all clients and they're all servers, or at least have the potential to all be clients and all be servers. This is sometimes referred to as individual resource sharing. In other words, you can share resources, but you can also prevent access to resources on your individual system, as can all of the other users. The traditional model of peer-to-peer networks, two or more general purpose computers, nothing fancy, any computer will do. And so you're capable of sending and receiving information to and from every other computer. So graphically, this is what it might look like. If you look at every computer on there, every computer is responsible in this system for its own data. So you can either share files or restrict access to the file, but it's done at each computer. So you can see, if you're trying to manage this from an administrator's perspective, it becomes very difficult because you're having to manage it at each individual computer, so that can be very problematic. So some of the advantages to a peer-to-peer network, it's a pretty simple configuration. You don't have to have any kind of special hardware, any kind of special software. It's less expensive than a client-server environment, so it certainly has certain advantages. Some of the disadvantages: it's not particularly flexible, it's not very secure, and it's not really practical for large installations. So the larger the organization, the more you want to move away from a peer-to-peer network environment. As far as resource sharing, you're able to modify file sharing controls, but it's the individual user's responsibility. Again, on your individual computer, you're going to either allow or deny access, and the other users that are on the network have that same responsibility. So you can see very quickly that different users are different. So various users are different. Some may be willing to share a lot of information, others may not be willing to share any information. So there's that issue of reciprocity that may be an issue depending on the needs of the network users. It's not centrally controlled, so again, that access may not be uniform, and it may not be secure. In other words, users may misconfigure access to a particular file or folder. So say, for example, you've got some very important files that you need to allow people to have access to, but they don't need the rights to modify those files. They only need to be able to view them. Well, if you have an inexperienced user and they accidentally allow access to those files and allow editing rights to those files, you may accidentally end up with bad edits or worse, deleted files. So it can be a problem. Peer-to-peer networks are best suited for small offices, for home environments. That's where they tend to work best. As far as larger networks on the internet, you do see Nutella, Bitcoin, the original Napsters. Those are all examples of peer-to-peer networks in a much larger scale. But again, those all represented some serious security issues that exist in large-scale peer-to-peer networks. When we're talking about networks in this perspective, or this type of modeling, opposite of peer-to-peer networks are client-server networks. And in the client-server networks, we've essentially got two major components. We've got the server and we've got the client. When we talk about the server is serving something up. It's a centralized computer that's going to share something. It's going to share some sort of a service, hence being a server. So it may be access to a printer, it may be access to storage or certain files or applications. So those are the things that it's serving up. The client, on the other hand, is consuming those services, consuming those resources. It's using the printer, it's using the files or the applications. Sometimes clients are just regular personal computers. Sometimes they're a little beefier machines, and they're what are considered workstations. But they're consuming those resources. So the server's responsibility is to control access to those resources. That's the server's responsibility. It determines what data is going to be shared, how that data is going to be shared. It creates storage space and determines how that's going to be shared. It determines access to various devices. So the sharing of the resources are not directly shared to the clients, rather the clients go through the server to gain access to those shared resources. So in this environment, the roles are a server and a client. The client is what's going to be able to run local applications and store data locally if the machines aren't locked down to restrict that. But it's also going to be able to run the applications and services and things like that from the server. And again, the server acts as an intermediary. The server is what controls access to those shared applications and devices. We need some sort of a device that operates in the middle, some sort of communication device. Often this is going to be a switch, a router, possibly a hub. There's a variety of number of devices, but there has to be something that helps us to connect these various computers in these roles. So again, graphically, this is what a client-server environment might look like. So you see, we've got several different we've got a couple different computers. We've got a server. We've got a printer. So in this example, let's say, for example, our client down here on the bottom right needs to print something. We can see that our printer is connected directly to probably a switch here. So you might tend to think that the workstation is going to print directly to the printer, and that may be true if we're in a peer-to-peer network. If, however, we're in a client-server environment, and the server or the client or the printer is being shared through the server as a print server, then what actually happens when you go to print a print job, the request actually goes to the server first. The server authenticates that user and determines if you have rights to print to the printer, and if you do, it okays the print job, and the print job is sent to the printer. So the server controls access to that print job. In a server environment, the server's got to have some sort of network operating system. It's going to manage the client data and the resources. It's going to ensure authorized access by authenticating users and looking at a list to see what rights you actually have. It's going to control user file access. It's going to restrict user network access to those who have rights to access the network. It's going to dictate what the communication rules are, what applications you have access to, and stuff like that. And then it's going to supply applications to clients. So some examples of various servers that are out there: Unix, Linux, Microsoft Server 2012, Mac OS X server. So there's a number of different types of servers that are out there. These are certainly the most common ones. Some of the features that a server has relative to a client: servers tend to have more memory. They process a lot of data for a lot of different clients, so they tend to have a lot more memory. They tend to have more processing capacity. In some cases, multiple processors, more cores, faster speed, etc. They also tend to have more storage capacity, so more hard drive space, more hard drives, and gives them more capacity to store things. They also tend to be equipped with special hardware. This may be to help provide additional network management functions. They may have extra network interface cards. They may have dual power supplies, things like that. Some of the disadvantages relative to peer-to-peer networks are a client-server environment tends to be more complex, both design and in terms of maintenance. So there are certain disadvantages to the client-server environment. Advantages, however, are that user credentials are all signed in one place. So rather than managing access on each individual computer, we simply manage those credentials in one place on the server, and that controls access to those individual clients. We have multiple shared resource access, centrally controlled, central problem monitoring, diagnostics, correction capabilities. Client-server environments are optimized to handle heavy processing loads. They can connect a lot of computers on the network, so it becomes more scalable. So as the network grows larger and larger, we don't run into some of the problems that we have in peer-to-peer environments. Another way of looking at networks, or another type of model, is whether or not it's a LAN, a MAN, or a WAN. There are actually other types of network environments as well that they don't really talk about in the book. There are PANs, for example, a personal area network, which you might be familiar with when you look at Bluetooth, maybe your phone connecting to your car. That's an example of a personal area network. Other examples are campus area networks, CANs, which you tend to see on university campuses or large corporations. But the ones that we're covering in the book are certainly the more popular ones: LANs, MANs, and WANs. And they all are really referring to the geographic scope of the devices that are connected. So a LAN is the smallest of the three. It's confined to a relatively small space, so it may be confined to a floor on a building, a floor in a building. It may be confined to an individual building, or perhaps a few buildings that are relatively close to each other. LAN's been around for quite some time, and they still continue to flourish today. Larger in scope is a metropolitan area network, and this tends to span the size of a city or maybe several cities. I know that Granbury, for example, has a metropolitan area network. The city of Denton does. It's becoming much more popular for cities to have a metropolitan area network in place. Whereas in a local area network environment, we tend to have access to the property and we can install cables wherever we want. In the metropolitan area network, that's not always the case. We may not own all of the property, so we may have to get permits to lay cable. We may have to lease lines. So there's a difference in terms of the control over our media and how we connect the different computers in a metropolitan area network environment as opposed to a local area network environment. So here's some kind of a graphical example of a LAN and how it's connected to other LANs via a WAN. So over here we have an example of a local area network. Everything's connected to a switch. So we'll get into this later in the semester, but what this means is all of these devices that are connected to this switch are on the same segment. They're all operating in the same address space, and so they can all talk to one another. But when we connect them via a router to another local area network, we're accessing them across either a metropolitan area network or a wide area network. And that's what allows us to communicate with different local area networks. And obviously the biggest wide area network, WAN, is the internet. So a WAN is really going to connect two or more geographically distinct LANs or MANs. So again, very dispersed, much larger in scope than a LAN or MAN. They span political boundaries, geographic boundaries. They potentially span the globe, such as the internet. They tend to use different transmission methods and media than local area networks. That is something, however, that is and has been changing. We do tend to see more fiber today than what we used to see in local area networks. At the same time, we're seeing some of those lower level protocols, such as Ethernet, being used in WAN environments. So that's something that's changing as well. As far as the network connection, it can separate offices in the same organization or perhaps different organizations. So again, an example of a WAN link connecting two different local area networks. So local area network over here, local area network over here. Our WAN connection is what allows this to communicate. So we may have a LAN connection in Los Angeles, another LAN connection in New York, and then we have a WAN connection that connects those two networks to each other so the computers on each side can talk to one another. Elements common to client-server networks include clients, servers, workstations, and there'll be several others on some of the next slides. But the client is what we talked about. It's a computer that's consuming resources. It requests access to resources from a server, and if the user has rights to, if that client machine has rights to it, it will be granted access. And when we talk about a client, we may be talking about an individual, so a human user. We may be talking about the software. We may be talking about the workstation itself. So when you hear client, you kind of need to know the context of the discussion to know specifically what's being referred to. When we talk about the server, this is the network computer that's sharing those resources, providing access to those resources. And it's going to run some sort of a network operating system, such as we talked about earlier, Windows Server 2012, for example. A workstation may be a personal computer, it may be a beefed up computer, but that's typically the client machine that's going to access those resources. Another important device is what's known as a network interface card, or a NIC. And this is a device that's usually inside the computer. It can be outside. Sometimes you have an external USB network interface card. But typically it's going to be inside. It can be a standalone card or a card that's plugged into the motherboard, or it can be something that's built onto the motherboard. And this is what's physically going to allow that computer to connect to the network media. Now, this can be a little bit confusing when we say physically connect. It may not be a physical cable. In many cases it is a physical cable. We have that network cable that we plug in. But it may be wireless. And so in that environment, when we talk about network media, we're talking about radio signals. But that's what allows us to communicate with other systems on the network. All of our devices have to have some sort of a network operating system, whether it be the client, it could be the server, it doesn't matter. They all have to have the ability to process the ones and zeros and put those ones and zeros on the network media. So regardless of whether it's wireless or wired, the network operating system is what's going to allow us to be able to do that. So here's an example of a motherboard. It's got a network interface card built onto the motherboard. This is probably just a regular client machine. In a lot of cases, servers will have multiple network interface cards built onto them, and so that gives you some built-in redundancy. A few other terms that you might hear when we talk about client-server environments, you might hear the terms host or node. In a lot of cases, these are the same things. A host is a computer that enables network resource sharing by other computers. And it really doesn't matter whether it's a client or a server. They're all hosts on that particular network. A node can be a client, a server, it can be another device as well. It's virtually any device that's on the network that communicates and has a unique network address. So we have lots and lots and lots of nodes that connect to our networks. So it could be an IP camera, for example. It could be an IP phone. Those are all examples of nodes. We've also got connectivity devices. These are what allow multiple networks or parts of a network to be able to connect and exchange data. So some examples of that are switches, for example, routers, hubs. Those are all different types of connectivity devices. Other terms are segments, backbones, and topologies. A segment is a group of nodes. And when we say group, we're talking about a group that are all able to communicate with one another. They operate in the same address space, which means they can all talk to one another, understand what's being said back and forth. So that's what we're talking about when we talk about a segment. If a computer's outside the segment, we need some sort of translation to go on. We need typically a router that's going to allow us to translate from one address space to another address space. Another term is backbone. A backbone is what's going to connect different segments to one another, and that's what allows us to operate across different types of networks or different networks. So in a sense, it's a network of networks, by definition, the internet. And the last term we have here is topology, and the book does not do a very good job of discussing topology. When we talk about topology, there is both a logical topology and a physical topology, and you really need to know which one you're talking about when you're discussing topology. They both represent similar things, but they're not exactly the same. The logical topology is referring to how the data is actually traveling the network. So how the data goes from one system to the next, how it goes to another client or to the server or out to the internet, things like that. As opposed to the physical topologies, physically, how is the media connected to one another? How are they physically connected? The book really focuses on the physical topology, and they present several different types of topology. There are others that are out there. They talk about ring, bus, star, or a hybrid formation, but there are others that are out there, such as mesh and partial mesh topologies. So here's an example of what a backbone might look like, and I disagree with the author here just a little bit. I'll point this out. To me, you don't really have a backbone here, or if you do, you would consider the router itself to be the backbone. Had this been a different network over here and this been a router here, then I would have considered this connection here the backbone itself. But the backbone is what's going to allow those different networks to be able to connect to one another and talk to one another. As far as physical topologies, here's some examples here of a bus, ring, star, and hybrid. In a bus topology, we have a single cable that's going to run, say, to this computer and back out to this computer and then back out over to this computer and then back out over to this computer. And this was a very early approach to connecting computers. It's very dated at this point. It tended to use coax cable to be able to do this. And one of the advantages was that it meant for a limited amount of cabling. So you could save money when it came to the amount of cable that needed to be installed. Unfortunately, this approach tends to have some limitations when it comes to network troubleshooting. For example, if you end up with a break in the cable here, these computers can talk and these computers can talk. These can't talk, these can't talk, these can't talk, these can't talk. So you end up with that sort of an issue. But again, the amount of cabling required is pretty cheap. Another approach is a ring topology, which again gives an advantage of a limited amount of cabling required. And data typically travels in a ring fashion, which works fine again until you end up with a break in that ring, and then you run into problems. But again, it gives you the advantage of having a limited amount of cabling. A star design is typically what you're going to see anymore, and the downside to this approach is it requires a lot more cabling to do this. Another weakness of this design is if your device here in the middle, a hub, a switch, whatever, fails, your entire network is down. Now, fortunately, these devices tend to be pretty robust anymore, and so that's not often a problem. But one of the real advantages to this design is that if you have a node that fails, a break in the wire, or a node that fails, that the rest of the network can continue to function just like normal because everything else is still connected and functioning normally. Something that's fairly common is some sort of a hybrid approach. So in a lot of cases, what they're showing here is a connection between a ring and then a connection to a star. A lot of times what will happen is you'll end up with something like this where you'll have a switch that's in a star configuration, and then that switch will be connected to another switch that is also in a star configuration. So it's a different type of hybrid network. Other elements common to client-server networks or terms that you need to be familiar with are things like protocols, packets, addressing, and transmission media. Protocols are a standard method or format for communication between network devices. So think of a protocol as how you might communicate with a friend. Normally you would speak to your friend, you would speak for a certain amount of time, you would finish your thought, and your friend would pick up on cues, both verbal and nonverbal cues, to determine that you're done speaking. And once they pick up on that cue, they understand it's their opportunity to speak themselves. And that's how the back and forth kind of goes. That's a protocol. It's a protocol for how you're going to speak. A computer needs that same type of protocol in place. They tend to, obviously, they're much more rigid in terms of exactly who can say what and when and how things have to be laid out. But it's a protocol nonetheless. It is a method for being able to communicate. A packet is a distinct group of data, and those that are exchanged between different nodes. So think of a packet as letters in every word that you speak. We create a packet to be able to send to our peers. When we speak to them, we group various packets together to create our entire message. Same thing with computers. We group different packets together to be able to send and receive files. To be able to get to the proper place, we use addressing schemes. And an addressing scheme is a scheme for assigning a unique identifying number to every node. So again, when we're talking to somebody, if we're talking to a friend in a group of people, we're looking that individual in the eye. We're talking directly to that person. Even though there are other people in the group, we're talking to a specific person. Same thing with computers. We need to be able to talk to an individual computer when we're trying to download a file, access a web page, etc. And that's where addressing comes in. And then we've got transmission media. This is a means through which data is transmitted and received. So our media may be wireless, so it's transmitted via wireless radio, via radio waves, microwaves, etc. Or it may be optical, so through fiber optic, or it may be through more traditional means such as unshielded twisted pair or twisted pair cabling. But we have to have some way of transporting those packets across our media to be able to get to their destination. So here's some examples of popular media. Coax cable, which we don't see all that often anymore, looks very similar to the kind of cable that you might have hooked up to your TV. It's a little bit different in the networking environment, but essentially it looks very similar. We've got shielded twisted pair or unshielded twisted pair, which essentially looks like telephone cable, if you're familiar with that. We use a few more conductors. It's 4 pairs of wires, so a total of 8 wires. Typically what you would see in this is certainly the most common, though wireless is becoming much more common as well. Typically when we talk about twisted pair, it's typically going to be unshielded twisted pair. It's cheap cable, it's easier to work with, and that's what you're typically going to see. If you work in an environment that has interference issues, you may invest a little bit more money and go with shielded twisted pair not quite as easy to work with, but for the most part still pretty easy to work with, and it costs just a little bit more. If security is a bigger deal or speed is a bigger deal, fiber optic cable, it can be a good way to go. Not as easy to work with, it costs quite a bit more, but the performance gains and the security that you get from it tends to be quite a bit better. A lot of the security comes from the fact that it's much more difficult to tap into a fiber optic cable than it is, say, shielded twisted pair or coax. And then the last example we have here are radio waves. Very convenient, becoming much more ubiquitous. We just really expect wireless access virtually everywhere we go anymore. So how are networks used? Well, they can be used in a lot of different ways. There's a lot of services that are provided by networks, and these include things like email, print sharing, file sharing, internet access, remote access, voice, network management. These are all things that we've come to expect our networks to be able to provide. So file and print services, these are probably the two most common services that we expect to be able to do on our network. File services allow us the ability to create files, share files, distribute files, store them, etc. Access is typically controlled by a file server, and it's really kind of the foundation of networking. Print services is closely related to that, and that's what allows us to access a shared network on the printer. So think of a lab environment. Rather than hooking up an individual printer to every single computer in the lab environment, you can have one or two printers and share them amongst that lab, and now you're going to save time in terms of configuring all those printers, maintaining those printers. You have fewer printers to maintain, so because of that you're going to save money, you're going to save time. You've also got access servers and services, and these allow you to remotely access network connections. So you may have virtual machines that you can access remotely. You may have office machines that you can access remotely. A lot of operating systems have remote access built into them, and this allows you to work at a distance. It's a real convenience. A lot of access services provide LAN connectivity when a WAN connection is not cost effective. So it's just another way to be able to access your stuff. And external staff in a lot of cases can access and diagnose problems via access services. So for example, here on campus, when you have a problem remotely, well, in a lot of cases with Blackboard, for example, you can call the Blackboard help desk. They can remote into your machine and make corrections right there. You can see what they're doing, and they can see the same thing that you're looking at and make corrections right there. So it's a way to help diagnose problems. And you can allow external users to use the network resources and devices, just as if you're logged in locally. Communication services is referring to our ability to use our computer to communicate. So there's this concept of convergence and unified communications, and these are kind of related. Convergence is offering multiple types of communication services on the same network. Unified communications is centralized management of multiple network-based communications. So it's this idea that we can have an application in which we manage email, fax, telephone calls, all within the same environment. And it's real convenient to have all of that stuff in one place. We've also got mail servers, which are managed through our communication services. It's responsible for storing email, transferring email to and from users, etc. Other tasks of mail servers, they can be used to intercept spam and help block a lot of that kind of stuff, handle objectionable content. It helps you to route messages according to various rules, so you may have certain users that need to be routed to a specific folder in your inbox. It notifies administrators or users if certain events occur. Perhaps your mailbox is filling up, so it notifies users you need to clean up your mailbox. Mail servers can schedule email transmission, so perhaps there's certain times of the day you don't want to tie up the network with mail services, so you may delay messages to a later time when the network's less congested. And it communicates with other mail servers on the network. Typically, mail server is going to run some sort of specialized mail server software, so it is a separate service or separate application on the server. You can also have web servers, so different types of internet services. A web server is a computer installed with appropriate software such as IIS or Apache to basically serve up web pages. And it serves up that content to clients asking for those particular web pages. Other internet services include FTP, file transfer capabilities, internet addressing schemes, so IP, security filters, and a means for directly logging on to other internet computers. Other management services include small network management. A lot of environments allow you to essentially load a small program on different devices throughout the network, and it reports back to the service how things are functioning, and back to the server how things are functioning. How effective is your network? Does it tend to get bogged down during certain times of the day? What kind of problems are you experiencing? Is there a network card that perhaps is being a little too chattery on the network? Perhaps it's starting to fail. So those management services gives the administrator a lot of insight into the performance of the network. In a lot of cases, you can fix issues more quickly that way. So again, allows you to monitor and control the network, allows you to balance, conduct load balancing, allows you to do diagnosis and failure alerts, allows you to manage assets and keep track of where your assets are, what assets you have on the network, things like that. Facilitates license tracking, helps you to do and conduct security audits, helps you to address management issues or manage address issues, and allows you to back up and restore data. So how do you get into this field? This is an exciting field. Information systems is really cool. Networking in particular, I really like. I think this is one of the really cool areas. Networking and security is kind of where it's at for me. So the job market is really good, especially in networking, especially in security right now. So there's lots and lots of computer professional jobs out there. It wasn't always the case. Around the year 2000, a few years after that, the market had really kind of retracted a bit. Before that, it was extremely good, but it's really rebounded quite a bit. If you take a look at the syllabus, where I provided some statistics from the Bureau of Labor Statistics, it tells you that most of the IS fields are growing at a pace faster than other fields. So that's a good sign if you're interested in becoming a networking professional. How do you prepare for entering the job market? Master general networking technology. So have a pretty good understanding of networking in general. Understand the content from this class. Have a general idea of Linux and how it works, and Windows Server 2012, how it works. But then pick a few areas that you really want to dive into a little bit deeper and know more about those specific areas. So much deeper in a few areas, whether it be security, it'd be some specific aspect about network design, something. Pick some area that you can go deep in. Hone your communication and teamwork skills. This is an area that a lot of students struggle with and don't particularly care to work in teams. They, especially younger students, aren't adept at communicating in a more professional environment yet. So work on these skills. Join various professional organizations. We'll talk about that a little bit later. But join some of those professional organizations and get out there and network and talk to people. The more you do it, the better you will get at it. So that's something you need to work on. Stay abreast of emerging technology. So work on your personal learning network. Follow people that are interesting on things like Twitter. Professionals that are in the field already that are really kind of at the top of their game, and follow the things that they're posting, the events that they're going to. Try to go to some of those events. Read the articles that they're reading. That's a great way to stay abreast of new technologies. Consider professional certification. We'll talk about this a little bit more here in a little bit too. Certifications are a way to set yourself apart, particularly when you graduate with a bachelor's degree. This is a big deal. That lots and lots and lots of people graduate with bachelor's degrees. Lots and lots and lots of people get certifications. Hopefully you can start to set yourself apart by having both a bachelor's degree and certifications. So do something. Give yourself a little bit of an edge. Just graduating with your bachelor's degrees, especially in today's job market, is probably not enough to get a potential employer to really take a hard look at you. Add to that bachelor's degree. And get to know others in your field. Again, going back to some of these previous comments, talk to them, network with people, follow people on Twitter, get out and about and talk to people. You've got to hone your communication and teamwork skills. So some of the skills to acquire: installing, configuring, and troubleshooting networks is obviously a great start. Understanding the characteristics of transmission media, understanding network design, network protocols, how users interact with the network, constructing a network with client servers, media, etc. You become a generalist in all of these different areas. Pick one, especially if networking is your thing. Pick one or two of these and get really good at that. Go really deep into those specific areas. Personally, I like network design. It's kind of one of my real interests. Master the technical challenges, continue. So pick one or two of those areas and concentrate on them. Specialties currently in high demand. Network security is a huge one. It's a really big one, and there's lots of subspecializations within that, such as forensics, network forensics, computer forensics, portable device forensics, for example. Get good at convergence. A lot of companies are trying to push everything onto the network, such as their phone and fax and all that kind of stuff. Get good at that. That's another way to kind of set yourself apart. Gain in-depth knowledge about one or more network operating systems, whether it be Unix or Linux or Mac OS X, whatever. Get good at network management, wireless network design, configuration of routers and switches, such as Cisco certifications, and centralized data storage and management. Another big one that's not on this list is virtualization. Get really good at that. It's saving companies a lot of money. There's a lot of interest in that, so if you're really good at it, you can certainly set yourself apart there as well. Develop those soft skills. Soft skills are not easily measurable. It's the ability to go out and talk to people, and it's the ability to communicate and get along. Those are all examples of soft skills, and it's not something that tends to interest people in information systems an awful lot. But if you don't develop those skills, it's going to make it harder to get a job, and it's going to make it harder to move up in an organization once you do get that job. So some examples of soft skills include customer relations, oral and written communications, dependability, showing up to work all the time, regularly, on time, etc. Teamwork and leadership ability, something we tend to suffer a lot at. So work on those skills, get better at those skills. As far as certification is something that here at Tarleton we really push a lot. I know in academia a lot of times certifications are not emphasized that much. We tend to have a little bit different perspective on that. We're big believers here at Tarleton in adding certifications to your degree because it does help to set you apart from your peers. So again, the certification process basically suggests or tells potential employers that you've mastered specific material. And so look at hardware, operating systems, programming languages, whatever it is, pick those areas and start pursuing certifications in those areas. And it suggests that once you've done that, once you've mastered those particular areas, it's showing that to a potential employer that you've got a mastery of that subject area. In general, there's a couple of different kinds of certifications. There are vendor neutral certifications, and then there are vendor specific certifications. Vendor neutral ones are ones like those put out by cont'd or TestOut that really aren't specific to any one particular vendor. So for example, here we've got CompTIA with Network Plus. They have A+ certification. They have Linux Plus certification. So they're not specific to any one vendor. They're rather more general certifications. These tend to be more entry level for the most part. It's not always the case, but they tend to be more entry level certification. Vendor specific ones are for specific products. So Microsoft has very specific certifications for their various servers, whether it be Exchange Server for email or Server 2012, etc. Cisco's another big one, especially in networking, router and switch configurations. Those are some of the big players for vendor-specific ones. Better pay, typically higher level beyond those entry-level certifications when you look at vendor-specific ones. Some of the benefits of pursuing certification, you tend to have, studies suggest that those with certification tend to get better salaries. You have more opportunities for jobs. A lot of job postings will list very specific certifications that they're looking for. There's professional respect, especially with certain certifications. CISSP, for example, is a very well-respected certification in the area of security. So they do command a certain amount of professional respect. And usually access to better support, especially with certifications such as Microsoft or Cisco. In a lot of cases, those individuals have access to a level of support that the general public does not have access to. As far as finding a job in networking, there's a variety of different ways. Searching the web, obviously, Monster and things like that. Checking the local newspapers' websites. Visiting the Career Center here on campus is a great way. You're paying for it in your student tuition, so why not visit them? They're really good at what they do over there. They can create mock interviews and help you with the interview process. They can help you create a video resume, which is sometimes a little bit different. Again, helps you set you apart from your peers. So take a look at it over there, and periodically they'll put on job fairs. So take advantage of that. Get over there and talk to those people in the Career Center. Network with like-minded professionals. So attend some of the career fairs I was just talking about with the Career Center. But network with like-minded professionals. Follow them on Twitter. Attend conferences. Follow them around career fairs if you happen to run into any of them there. Get their cards and talk to them. And then lastly, enlist a recruiter. I'm not a big fan of this option, but it is a potential option, so be aware of that. Something you can do that I think is really beneficial is join a professional organization. There are a number of those out there. Here on Tarleton's campus, we have AITP. We have a chapter for that. There are others that are out there. There's ISA, for example. There's ACM. There's a number of different professional organizations that you can potentially join, but it allows you to connect with people that have a similar interest. It facilitates new learning opportunities. There can be various topics that are shared amongst members, and so it allows you to stay abreast of current things that are going on in the field. They typically have some sort of specialized information access because they're a larger organization. They can a lot of times have insight into manufacturers and companies that sometimes as an individual you can't gain. In some cases they have tangible assets, free goods for example. And the couple of bullet points down there later it says free software and free release software. Go to a lot of these Microsoft things that they put on. In a lot of cases they'll give away free software. That's really cool. It's a good way to get exposed to things. Attend technical workshops and conferences and access publications. A lot of times you have those by joining professional associations, and again, those are good ways to be exposed to the latest and greatest. And then lastly, hardware lab access. In some cases, you'll have a lab that you can actually go and practice things and learn things. So here's a list of some of the more prominent professional associations. There's, like I said, there are others out there. There is ISA, which I'm a member of, but there are a lot of others out there as well. It really depends on your specific interest, and again, it has that breadth versus depth kind of thing. ACM, AITP tend to be very broad in nature versus something like ISA, which is focuses on security, tends to have more depth in the area of security specifically. So in summary, we talked about a network, what a network is, what the advantages are of using a network. We talked about some of the different types of network models, specifically peer-to-peer and client-server, as opposed to LANs, MANs, and WANs. We talked about networks providing a wide range of services like file and print services and network management and stuff like that. And then we talked about job preparation and the importance of getting out there and networking with peers, picking some specializations, and the need to consider certification. So that is chapter 1 in a nutshell. Hope you enjoyed it. Hope you get a lot out of this chapter. If you have any questions, send me a message, shoot me an email, get in touch with me. Follow me on Twitter at H.Schuessler, PhD, or follow me on Google+, and keep in touch. Take care.